3.4 in college algebra, it has two objectives. The first objective is to solve rational equations, which means your equations with these ugly fractions in them. And then objective 2 is to solve radical equations. So that's what we'll do in the back. It's where we have radicals in the equations. So one way you could do this is, if you wanted to, you could find an LCD for each of these, convert them to equivalent fractions, add them up and solve. Or what we can do, and you can read it right here, it says, radical equations are equations containing rational expressions, fractions. How do we solve these equations? You get rid of the fractions by multiplying both sides, essentially every single term. So we're going to multiply every single term by the LCD, okay? So that's why we just had the lesson about finding LCDs, and then also how to simplify rationals, because what we're going to do is we're going to find the LCD for everything, but when you multiply by it, the LCD up top will cancel out with one of the factors in the bottom, and we'll essentially get rid of the fractions, okay? So over here, let's look to the side. What's going to be our LCD for example 1? What's the LCD between 3 and 2? 6. So what we're going to do is we're going to take 6 and we're going to multiply x minus 8 over 3 by 6. We're going to take 6 and multiply x minus 3 over 2 by 6. And we're going to take 6 and multiply 0 by it. So notice I have the original equation, x minus 8 over 3, x minus 3 over 2, and 0 all in parentheses. But what we're going to do is we're going to multiply every single term by 6, because whatever I do to the left, I do to the right. I'm keeping my equation balanced. But when we do that, you're going to see the 3.4a come into play, how we can reduce rationals if there's a factor on top that cancel out with a factor on the bottom. So what do you notice about this 3 and the 6 if the 3 is on the bottom and the 6 is up top? What's going to happen with the 3 and the 6? We're not going to multiply them because one's on top and one's on bottom.
3 and the 6?
Mm-hmm.
They cancel?
They cancel, and the 3 will disappear and the 6 will become a 2. So now we're left with 2 times x minus 8.
So it's the 6?
On top. So you could really put it 6 over 1 if you wanted.
Okay.
So you can distinguish top from bottom, okay? What about when we move on to the second term, what happens with the 6 and the 2? The 2 will cancel and the 6 will become a 3. So we'll have 3 times x minus 3. And over here, I did this just in case you had a number other than 0. Don't forget to multiply the right side. But 6 times 0 is just 0. At that point, we now have an equation that we can solve with no fractions, okay? So what we're going to do is we're going to distribute our 2, distribute our 3, gather like terms. And the one thing at the very end is, even if we don't check to make sure the answer on the left equals the answer on the right, we do have to check that our answer is in the domain. Remember, domain, we do not want the denominators to be 0, so we have to keep that in mind. Okay, so if some of you already solved this, I'm going to go ahead and do it. So we'll have 2x minus 16 plus 3x minus 9 equals 0. Gather like terms, so that's 5x minus 25 equals 0. So remember, when you're gathering like terms, as long as they're on the same side of the equation, you can just do the math that's there. You don't have to do this opposite side. But then when you want to move them to the other side, that's when you do the opposite operation. So how we're going to get the x by itself, what do we have to do?
Plus 25.
Add 25 over, and then do what? Divide by 5. So what does that mean? It means 5 is the answer. And this one's not too hard to put in our calculator, or even just do in our head. 5, when we put it in here, what's 5 minus 8? Negative 3, right? What's negative 3 divided by 3? Negative 1. Keep that in your head, okay? What is 5 minus 3? 2. What's 2 over 2? Positive 1. What's negative 1 plus positive 1? 0. So we've solved for the unknown. Is 5 okay? Is it in our domain? Well, yes. Look at our fractions, guys. Both of them are solid numbers, 3 and 2. There's no way either of those denominators are going to be 0. So any number would have been fine. All right, let's move over to example 2. What's going to be our LCD for 2, x, and 3?
6.
Yeah, because what do we need? A 2, an x, and a 3, right? And so our LCD will be 6x. And we're going to do the exact same thing. Multiply 1/2, 2 over x, 1/3, and 3 over x, all by 6x. And if you want to put the 6x over 1, just so you don't confuse where his location is, feel free to do that. All right, so start canceling out terms. The 6x with the 2 will disappear, and the 6x will become a 3x. Times 1, and I'm doing that just in case that was any other number other than 1. The second part, the x's cancel out. It's kind of hard to cancel out an x. You kind of have to squiggle them out. And you're left with 6 times 2. On the other side of the equation, the 3 cancels out the 6 to make a 2. So you have 2x times 1. And then again, the x's will cancel out, and you're left with 6 times 3. All right. Multiply to get rid of your parentheses. So we'll have 3x times 1 is 3x. 6 times 2 is 12. 2x times 1 is 2x. And 6 times 3 is 18. At this point, you want to get all the x's to one side. So I'm going to subtract my 2x over to the other side. So I'm left with x plus 12 equals 18. And then to get x by itself, I'm going to subtract the 12 over. So you get x equals 6. Is that what you guys got? Are you still working on it?
Yeah, x equals 6.
You get 6? Okay. And Gavin, you keep working on it. Let me see what you get once you get done. Once you get your answer, you can plug it back in. So like technically on the left-hand side, we'd have 1/2 plus 2 6, and we would see what that answer was. And on the right, we'd have 1/3 plus 3 6, and we'd see what that answer was. And as long as the left equaled the right, we'd be okay. You want me to double check? I can double check
I
this.
had a -6 for some reason. Maybe I just
There shouldn't be, so you should have pauses throughout the whole thing. Did you maybe move your 18 over to the other side? Okay, I'll look at it.
No,
real quick.
no, I didn't.
Okay, do you see it?
Yeah.
Okay. So, and then the second thing, guys, looking at our original equation, what's the one thing we wouldn't want x to be? We wouldn't want x to be 0, right? Because 0 is not in our domain, but we got 6. That was fine. So that is our answer there. All right, let's look at the next one. So these next two are going to be more in depth where we're going to actually have to factor. So x plus 5 and x minus 5, but what's this actually factor to?
X times x plus 5 minus 5.
X plus 5 times x minus 5, like that, right?
Yeah.
The difference of squares. So I'm actually going to cross them out, and I'm not going to even think of him as a difference of 2 squares. I'm going to think of him as that product. So what's the LCD going to be? Those two factors, x plus 5 and x minus 5. Do you guys agree? Because the first guy needs x plus 5, the second guy needs x minus 5, and the third guy needs both of them. So this one gets kind of long. You can kind of see what's going to start happening. I actually write it all out, so I kind of creep into my example 4. So I'm going to try to write a little bit smaller. X plus 5 times x minus 5 times the quantity 2 over x plus 5 plus x plus 5 times x minus 5 times the quantity 1 over x minus 5 equals x plus 5 times x minus 5 times the quantity 16. And instead of writing it over x squared minus 25, I'm going to leave it factored out so I can see that it factors and cancels completely. All right, so I wrote really small, but you guys can kind of see what's going to happen. I think a lot of you can just visually see what's going to happen. So with the first one, you'll see that the x plus 5s are going to cancel out. So really, you could have just left it with 2 times the x minus 5 if you can kind of see that happening. So this x plus 5 is going to cancel out with that x plus 5, so we'll have 2 times x minus 5. Over here, we'll have x minus 5 times x minus 5 will cancel out. So you have 1 times x plus 5. And again, I'm writing it like that just in case that 1 was anything other than 1. And then over here, since I wrote it exactly factored out, I can see it exactly cancels. And so you're just left with 16 there. And what we've done by multiplying by our LCD, guys, is that we've gotten rid of our fractions, and we have an equation where we can just distribute and solve. All right, so I'm going to distribute the 2. I'll have 2x minus 10. Distribute the 1. I really didn't need to. That's just x plus 5 equals 16. Does that look okay so far? Gather like terms. So 2x plus x gives us 3x. Negative 10 plus 5 gives us a negative 5 equals 16. So when they're on the same side of the equal sign, remember, do the math. Don't do that opposite operation until you want to move him over. All right, so I'm going to add the 5 over to get 3x equals 21, and then I'm going to divide by 3 and get x equals 7. Does that look like what you guys got? Let me know if I'm going too quickly there.
7?
Mhm.
Oh, okay.
That's what I got.
7.
And again, what you want to do is you, what'd you say?
I said, yeah, I got
Okay, perfect. And all we want to do is double check. Like I said, we could double check to make sure the left equals the right, but we don't necessarily have to do that. We just want to make sure it's in our domain. So go up here. What are the two things that are not in our domain? -5 and 5, right? -5 would make that first denominator 0, and 5 would make the second denominator 0. 7 is not either one of those, so 7 is our answer. All right. So the last one's really similar to that, where x plus 2 is needed. X is needed, and what is the second or the third denominator factor to? What can you pull out of the third denominator? That x. So notice the LCD is just going to be each of those individually, right? And again, I kind of got in my own way, so I'm going to go like this. All right, so we'll go down here. So I'm going to take each of these terms and multiply by my LCD of x times x plus 2. So x times x plus 2 times the quantity 3x over x plus 2 plus x times x plus 2 times the quantity 6 over x equals x times x plus 2 times the quantity 12 over x times x plus 2. So I'm not even considering it as x squared plus 2x anymore. Okay? But you don't have to show me all that work. If you're going to see that the x plus 2 is going to cancel out with that first fraction and just leave you with an x times the 3x, you can go right to that part. Okay? So the x plus 2's are going to cancel, so you're left with x times 3x. The x's are going to, again, the x's are kind of hard to cancel, so you're left with 6 times x plus 2. And over here, the x and the x plus 2 is going to cancel, so you're left with 12. At that point, we're going to distribute, and we're going to get this quadratic popping out, this x squared. A lot of times when that quadratic pops out, sometimes one or the other, or maybe both of the answers don't end up working. Okay, so this is 3x squared plus 6x plus 12 equals 12. So this is what's hard about this section is, up until now, examples 1, 2, and 3 were just a linear equation. What do I mean? The x was just to the first degree. And all of a sudden we have a quadratic. But keep in mind all the rules of quadratics. You can use the AC method, quadratic formula, square root method, all that stuff. But here, this one's nice and factorable because what do you notice about the two 12s? Like if you wanted to get the 12s together, what happens? They end up canceling each other out, right? No matter which direction you go. So we can subtract 12 from both sides, and I'll leave you with 3x squared plus 6x equals 0, correct? And then that is just a factorable quadratic where we can just factor out a GCF. What can we take out of 3x squared plus 6x?
3x.
A 3x. When I factor out that 3x, what does that leave you with?
X plus 2.
X plus 2. So when you solve each of those, you need to solve the 3x equal to 0 and the x plus 2 equal to 0. So we'll have the 3x equal to 0 and the x plus 2 equal to 0. So x is either 0 or -2. And the question is, can it be either one? So we go up here. Can it be -2?
Yes.
What happens if you plug -2 in?
No.
No, right? Can it be 0? No. So this one, even though we did all this work, the answer is no solution. Isn't that awful? And I'm going to make a note of why it's no solution, guys. I'm going to say how these are not in the domain. Okay? So again, even though you don't plug it back in to check the left equals the right, make sure if you plug it back in, it's not making the denominator equal to 0. Okay? Are there any questions with the rational equations? Find the LCD, use the LCD to knock out all the fractions, and then just solve the remaining equation. All right, on the other side, I don't know why there's a line through it. Something happened with the copier. I apologize for that. On the other side, we have radical equations, and what they are is they're equations that contain at least one radical. So how do we solve it? We just isolate the radical. So you get the radical by itself as if it's the variable. And then how do you undo square? You square root. So how do you undo a square root? You square, okay? So to get rid of a square root, we're going to square. To get rid of a cube root, we're going to cube. To get rid of a 100th root, you're going to raise it to the 100th power. But you must isolate that radical first. So in this one, notice that radicals are already isolated. So we're going to take that isolated radical and square it, because the opposite of square rooting is squaring. But if you do it to the left, you have to make sure you do it to the right. Okay? So on the left-hand side, what happens with the square and square root? They undo each other. So guess who gets to pop out? The 3x plus the 1, okay? On the right-hand side, what's 4 squared? 16. Subtract the 1. You have 3x equals 15. Divide by 3, and you get x equals 5. Okay? These ones aren't too bad to check. If you throw 5 back in for x, what's 5 times 3? 15. What's 15 plus 1? 16. What's the square root of 16? 4. So you know you did it correctly. All right, 6 is a little bit more complicated because we need to isolate this radical. So we need to isolate him. So who's in our way? Who do we want to move over? The 5. How are we going to move him over since he's positive? Subtract him, and can we combine him with the x? No. So it's just going to be the square root of x plus 7 equals x minus 5, like that. Is that okay so far? All right, so how do we get rid of a square root? We need to square. But if we square the left, we have to make sure we square the right, and this will be a little bit more tedious than just squaring a number, right? We're going to have to FOIL. The left-hand side's easy. What happens when you square a square root? They undo each other, so the inside x plus 7 comes out. On the right-hand side, what's x minus 5 squared? It's x minus 5 times x minus 5, right? It's not x squared plus 25 or x squared minus 25. We're going to have to FOIL that, all right? So let x plus 7 hang out as we FOIL this. X times x is x squared. X times a negative 5 is a negative 5x. Okay, we're done distributing that x. Let's distribute the negative 5. Negative 5 times x is a negative 5x. And then negative 5 times negative 5 is a positive 25. So we're left with x plus 7 equals x squared minus 10x plus 25. Whew, that's a lot. Okay, so what happened again is what happened on number 4. On number 4, on the front page, a quadratic came out. So let's get everything to one side, set equal to 0, and factor this bad boy, okay? So I'm going to subtract the x over from the 10, and I'm going to subtract the 7 over from the 25. I'm going to do them at the same time. So these all cancel. So I have 0 equals, I did nothing with my x squared, so he's going to stay x squared. What's 10x take away another x? Negative 11x. And what's 25 take away 7? 18. Is that okay? So again, for purposes of just time, what are factors of 18 that add up to a negative 11? Are we okay there, Gavin? Sorry.
Yeah,
You see it? So what I did was I FOILed, and I got x squared minus 10x plus 25 on the right. Is that okay?
Yeah.
And then I want to get everything to one side equal to 0 so I can factor. So I did them at the same time. So I moved the positive x over by subtracting it from the 10x, so that's where the negative 11x came from. And I moved the positive 7 over from subtracting it, and that's where the 18 came from. Is that okay?
Yeah.
So what are factors of 18 that add up to 11? 9 and 2, but they both need to be negative in order to multiply to be positive. Again, AC method, little magic wand waving here. I'm just going to go right to the answer. It's x minus 9, x minus 2. Okay, so you do the AC method to get there. So what are your two potential answers? We're going to set each of these equal to 0. So x equals either 9 or 2 or both or none or 1. Okay, so we have all those. Is that okay so far? Do you get the 9 and 2? Okay, so this one we do have to check because a lot of times it's called an extraneous solution. An extra guy pops up that's not really true. So let's try the 9. We're going to plug them into both sides. So we'll plug 9 in here. What's 9 plus 7? 16. What's the square root of 16?
4.
What's 5 plus 4?
9.
9. And that's what our x was. So the 9 works for sure. So we'll circle him. Let's do it with 2. What's 2 plus 7?
9.
What's the square root of 9?
3.
What's 5 plus 3?
8.
Which is not x of 2, correct? So this is not a no solution. This is, hey, it's only one of the two that I actually found. All right, so the last two are actually even easier than the first two, okay? So on number 7, what we want to do is we want to isolate this root. So who's in our way? This plus 3. So we'll move him over. 5x minus 2 equals a negative 3. Is that okay, guys? So if squaring undoes a square root, how do you undo a cube root? You cube. And can a cube root equal a negative? Yes. Remember, we can take cube roots of negative numbers. So this is okay. So we're just going to cube the cube root.
If you decided to cube the 3 on the same side, would that work?
No. So you have to isolate it. Yes. So that's
Okay.
something that people try to play around with. The whole idea of square rooting or cubing is because you have that radical isolated. All right. On the left-hand side, the 5x minus 2 will pop out. On the right-hand side, what do you get for negative 3 cubed?
27.
Negative 27. Add your 2 over. You get 5x equals a negative 25. Divide by 5 and you get x equals a negative 5. Again, it's not horrible to check. Let's plug it back in. So 5 times negative 5 is a negative 25. A negative 25 minus 2 is a negative 27. What's the cube root of negative 27? Negative 3.
Yeah.
And then negative 3 plus 3 is 0. So that's right. All right, so remember how I said a cube root, or I should say an odd root, can equal a negative. All right? So let's isolate this radical. The square root of x plus 1, we got to move the 3 over, so that right-hand side will become what? What's 2 minus 3?
Negative 1.
Negative 1. Can a square root equal a negative?
No.
Not in our real solution. So even though we know I and all that stuff, when it comes to solving equations, we're not going to solve equations with i's, okay? So this one, once you isolate the radical and it's an even root equal to a negative number, you say there's no real solution. No real solution, okay? So, say you didn't notice that. You guys do not have to write this down, just kind of follow along with me. Say you didn't notice that when you moved it over that it was a negative, you just went about your way. You're like, okay, how do I get rid of a square? I'm going to square root. I'm going to square both sides. So notice what happens. We'll get the square root of x plus 1 squared equals negative 1 squared. The square and the square root undo each other, which is x plus 1. You square the negative 1, which comes positive 1. Subtract the 1 over, so you get x equals 0. But whatever you get when you plug it back into the original, it will not work. Okay? So if you put 0 in here, 0 plus 1 is 1. The square root of 1 is 1. 1 plus 3 is 4, not 2. So even if you don't notice it here, and you do all this work that you shouldn't be doing, you should at least get no solution either way, because the solution you found didn't technically work.